Hello everyone, welcome to module 1, which is Introduction to R. In this module, we will be understanding basic concepts regarding R. We'll start with what is R programming language and why it is used. Especially in biology, it's a very famous language. There are so many things you can do. Let's start with the point 1, which is R was developed in the early 1990s by Ross Ihaka and Robert Youngman at the University of Auckland, New Zealand. The second one is it is inspired by S programming language. So R programming language is connected with S programming language, which was developed in Bell Laboratories in 1970s. So that means you can understand R programming language is not new. It's there, but now it's being used in various applications, especially in biotechnology and biology. The first official version of R, which is v1.0.0, was released in February 2000. And this was the version that was the first version, and after that it got really famous because you can do a lot of amazing things using R. R stands for Ross and Roberts because the names they are starting with R. That is why the language is known as R programming language. The inventor for R is Ross and Roberts, and these are the two people who actually democratized data analysis. They made data analysis available because you can freely use R. It is open source. There are so many tools that are available for you. So it's very famous, especially among researchers, especially among various organizations, various universities, academics. Lots of people are using R, and I'll tell you why it is so amazing. There are so many things you can do, especially when it comes to statistical analysis. R is the top-notch programming language that you can use. The next thing that is very important is CRAN, the Comprehensive R Archive Network. There are so many things that are there in CRAN. It was basically developed in 2001 to 2010, and a lot of various things are getting added in this particular network. After that, after 2012 onwards, there is a rapid rise of other features. For example, ggplot1, ggplot2, dplyr, you have tidyverse, you have shiny. So many advanced features are available if you're using R. Integration with bioinformatics, you can integrate bioinformatics with R programming language by using Studio. RStudio, that is what we are going to use for our data analysis and understanding the R programming language. This is the foundation course, so we'll not go very deep into that one, but what it will provide you, it will give you a lot of fundamental information and how you can use R to basically do data visualization. But there are other tools that are used for bioinformatics, detailed bioinformatics analysis, as well as machine learning and data visualization tools, especially the advanced data visualization tools. Next is, now it is being used in academia very frequently, healthcare, pharma, biotechnology. So many people are using R, and if you want to analyze and get very high quality, professional quality plots, R is something you should be using. Now let's talk about use of R programming language. R is an open source programming language designed specifically for statistical analysis. That is what I told you. Data science and visualization tasks. If you have a data and you want to visualize data very effectively and you don't want to program too much, R is something you should be using. And nowadays, because of the AI, R is becoming more and more famous because you can get codes for R very easily. You can write scripts very easily that can analyze your data and visualize your data effectively. So you can create amazing plots in R, especially using RStudios. You have a lot of freedom to create amazing plots. It was originally developed for statisticians. So R was the language that was developed for statisticians, but then it was adopted away in different scientific fields, especially biology and biotechnology. It was specially adopted for various tasks. So it's a really famous programming language when it comes to analyzing data in biology and biotechnology. Now, handling biotech data, we need to talk about that also. Point number 1 is R efficiently analyze tabular experimental data, such as growth curves, enzyme assays, and patient clinical records, because all that data is tabular data. Lots of experimental data is tabular data, so it can handle that particular data very effectively. Second one is its data frame structure and built-in statistical function makes it idle for processing lab results and experimental data sets. If you have a lot of data and you want to analyze the data, there are lots of built-in statistical functions that you can use in R. Bioinformatics with R. So bioinformatics, especially there is a feature which is open source software for bioinformatics, which is Bioconductor. It is R-based, and the Bioconductor project offers hundreds of R packages that are optimized for genomic if you have genomic data, transcriptomic data, and also proteomics workflow. So the bioconductor is something that you can use, and it's also open source software for bioinformatics. It's R based. Next is high quality visualization that you can do with R programming language, especially with ggplot2. You can create publication quality figures using libraries like ggplot. You have matplot library in Python. You have ggplot library, which enables clear visual communication of research findings. So this provides you a lot of opportunities to create amazing plots, and those plots are really high quality. Another point is reproducible research in biotechnology, and why reproducible research in biotechnology is important. As you can see over here, R supports reproducible research through script-based analysis. You will create a particular script, and if you have a data that you have analyzed using that script, and if you have another data that you can again reanalyze with the same script, what is going to happen is there will be less bias in analyzing the data, and all the plots that you're getting are going to have a kind of same workflow, and you will create consistent analysis pipeline, and it is reproducible because you can use and share these scripts with another researchers, and they are going to use them for their own research, and probably they are going to get same results, especially when it comes to the data analysis part. So in this particular process, you can get reproducible research, and your workflow documentation will be more standardized. So you can have R markdown notebooks and also workflow documentation. By using R, you can have more effective reproducible research in biotechnology. Next is sharing R code ensures transparency. You can also share the code with another researcher, and if they are able to repeat it, that means your research is reproducible, and it's also important for collaborative research and also for peer review, because sometimes reviewers are going to ask you that provide us a script that you have used for data analysis, and it becomes very important. If you provide that at the time, then your paper is going to get accepted, and the chances are high when you provide those kind of analysis scripts to the reviewers. So all right, that was all regarding the introduction of the R programming language. All these aspects are really important. That is why it's an amazing programming language for biotechnologists, and that is what we are going to do. We are going to analyze the biotechnology data. I'm going to give you a foundation overview of R programming language. At the same time, I also equipped you how you can plot, how you can analyze your data, especially the data that we have in biotechnology. Right, let's move on to the next part.